Hello guys, this is your instructor Mac and today we'll be doing the last lecture regarding motions and it's again going to be containing just the past paper questions. I've compiled everything for you guys. Just stay tuned and inshallah once we're done with the lecture you'll be very well aware of what the questions are and how they can be asked in the examination regarding the graph chapter. Okay. Now the question states that there's a velocity time graph for the car for the first part of the journey, and as the velocity of the car increased, the driver changed gear. Each change in gear produced a small decrease in velocity. State how the graph shows that third gear has a smaller acceleration than the first gear. If you would realize that third gear, the steepness is less, the gradient of the third gear is less than the first gear, and since the gradient of velocity time graph gives us acceleration, so third gear would have a lesser acceleration compared to the first gear. You can just safely say it's state question, so stay very focused and just on the point. First gear has gradient value greater than the third gear. So yeah, moving on. Determine the average acceleration when the car is accelerating in second gear. Okay, so in the second gear, you average acceleration is needed. So you just have, it's basically a straight line. So yeah, you would have two values. I would take two values. First, I'm going to be taking this, or you can take whole numbers as well, whatever suits you. You can take this value, and this is going to be 10 and 13. Well, this is 10 and 13, and this is going to be 6 and 8.4. Yeah, 8.4. Okay. 10, 13, 6 and 8.4. So 10, 13, 6 and 8.4. Y2 minus Y1 over X2 minus X1. You can just calculate the gradient. 13 minus 8.4, and answer is to be divided by 10 minus 6. You would get a value that's 1.15 meters per second squared. You don't need to worry about this. There's a huge range in your answers when these types of questions comes up. All right, moving on to the next one. Oh, this is a good question. This is a very good question. A man dives from a platform into the swimming pool. The platform is 12 meters above the water surface as shown. The graph shows the vertical displacement of the man from the water surface after leaving the platform. State how the graph shows that the man's initial vertical velocity is 0. Graph is horizontal. It's a displacement time graph. Graph is horizontal, 0 gradient. So the gradient of displacement time graph gives us velocity, and if something is not moving with a velocity, that means the gradient is going to be 0. And you can clearly safely say that it's 0. You can even write that if you draw a tangent, it is going to be horizontal, so it's the same thing. Don't need to worry about that. Determine the vertical velocity of the man as he enters the water. Okay, so I need the velocity of the man as it enters the water. So I basically practically need this gradient, this red line gradient, because this is the point where it enters the water, and at that point the displacement would be 0. It's 12 meter below, and at 12 meter below, this is the point. And the gradient, I need 2 points. I can take this one. First of all, I'll take the point exactly. That's 1.5 and 0. Reduce answer error chances. And the second one, I can take this. That's going to be 1.1 and 5. Okay, 6 and a 5.5. Yes. So 1.5 and 0. And 1.1 and 5.5. All right. Well, my answer would be coming in negative since the graph is like negative gradient curve. So my answer would definitely be negative. And what would my answer be? It would be negative 13.75. So negative 13.8 meter per second. Okay, before entering the water, the man has a constant vertical acceleration. Well, the man has a constant vertical acceleration. If the velocity is increasing in negative, if the velocity is increasing in negative, that means if I would have to draw a velocity time graph, it would look somewhat like this because it's uniform acceleration in negative direction. Kids, I'm going to be sharing this one more time. If you are not 100% conceptually understood by the concept that I gave you in the graphs initially, my kids, this is going to be very haunting for you. You have to be very, very good at your concepts. What is happening, how is happening, otherwise things are going to be very complicated. So it's going to be like negative acceleration throughout. It's going to be negative 13.8 meters per second. So graph is going to look like something like this. So from 0 it's going to be negative 13.8 and it is reached around at 1.5 seconds. So till 1.5 is going to be a uniform acceleration of negative 13.8. So yeah, negative 13.8. Something like over here somewhere. This would be the shape. And moving on. And then at time 2.1 seconds, it kind of came back to rest in the water, and it's saying that it's going to be constant vertical deceleration. This is vertical acceleration in the negative direction, and deceleration means it's going to go like this. Again, we have discussed each and every graph individually. It's deceleration in the negative direction, so it's going to be and the time is given as 2.1. So till 2.1 the graph is going to come to rest. So this is going to be the shape of the graph for 2 marks, and this is extremely important question. A little bit, not extremely, this little overhead because it's 1.5. Yeah, I've drawn it a little wrong. Okay. Well, that's it. This is going to be the shape of the graph when it comes to a velocity time graph for this particular concept. Try understanding it. Pause the video, replay it again so that you understand this. Okay. Now it is saying that the graph shows how the velocity of an object varies with time. So this is how the velocity is varying with time. Describe how the acceleration of the object varies with time. Use your answer. Answer should include calculations. Okay. Acceleration is varying with time. All right, sir. Very good. Okay. So this is the first part of the journey. And in this part of the journey, the object is accelerating. The velocity is increasing. So this is acceleration. And this just going to be marking it. This is acceleration. Acceleration and positive acceleration, like positive direction. This part of the journey shows deceleration because the velocity is decreasing, and this basically is deceleration in the positive direction. And from here to here, this part of the journey is acceleration in the opposite direction. So this is acceleration in opposite direction because velocity's magnitude is increasing. If you can clearly observe, the velocity from 0 is increasing in negative. That means the object is going in the other way, like the negative direction, and then it's increasing velocity, like it's basically accelerating. It's still uniform acceleration. Okay. Describe how the acceleration of the object varies with time. So you can clearly say, safely say from 0 to 8 seconds. Graph is accelerating, object is accelerating. And then you can put the values as well. So I'll find the gradient. It would be 8, and then that's around 14. Yes, 8, 14. So just get the acceleration. 14 divided by 8. Since it starts from 0, I don't have to do this, but if you wish, The value of the acceleration is going to be 1.75 at 1.75 meter per second square. All right. From time 8 to 11, 12, somewhere around 11.5 seconds, 11.75 seconds. Yeah. From time 8 seconds to 11.75 seconds, object is decelerating. And the deceleration value I can calculate by the gradient of these 2 points. It's 11.75 and 0. So first coordinate is going to be 11.75 and 0, and the second one is going to be 8 and 14. So I'm going to be plugging in the values. 14 minus 0 over 8 minus 11.75, and you would get the negative answer of decelerating this calculation right somewhere in the corner so that the examiner can see that, and at negative 3.73 meter per second square. And then you can safely say from time 11.75 to around 17.5, from time 11.75 to 17.5 or 17.25, object is accelerating in the negative direction. So object is accelerating in the negative direction at negative 3.73 meters per second square. This negative indicates that the velocity is being increasing in like negative. So it's negative acceleration it can be acceleration, it can be deceleration, depends upon the question, but you have to actually analyze the graph and you should know what is happening in the graph. So this is 3 marks. I've wrote a lot of details. Might be possible that you miss a couple of points and still get full marks, but since it's explanation point of view, I'm going to be writing everything. All right. There's one last question that I want you guys to do it yourself. I'm just going to be verbally explaining it so that you can attempt it yourself, and we are done with the whole concept of motion and graphs. Draw the corresponding velocity time graph for the motion of the swimmer on the axis below. Show all your working. So first of all, you're going to be getting the gradient of this, and you're going to be getting a gradient around till this point. So it's going to be around somewhere around 41. So that gradient is going to be somewhere like this, and then the velocity is like 0. So the velocity for that time to this time, the velocity will be like coming to 0, and then the gradient is negative. So the object starts, and then the velocity again becomes constant negatively. So the graph shape is going to be looking somewhere like this. First you need to get this gradient that shows that the object is like basically moving at a uniform velocity in the positive direction, that it's like sort of bounces off or something, or like the swimmers are like going inside and then coming out. A swimmer swims 100-meter race. Okay, so it's basically like uniform velocity in the positive direction, and then it touches and came back with the uniform velocity in the negative direction. So that's what the swimmer is doing. So you get these two gradients. These two gradients are going to be plotted over here, and then this time in the center is going to be the time of contact. So it's going to be like looking somewhere like this. The graph shape is going to be looking somewhere like this, and this is going to be exactly the shape of the graph. Get the gradient. If you're stuck somewhere, you can always ask me. All right, and then we have got B part to it. I want you guys to actually attempt this question, and I'll have the recording of this eventually. And if somebody is stuck, they can always email me and I'll share the link of the recording, this question as well. I'm hoping that you guys understood the concept. This is exceptionally good lectures. Make sure to share it with all your friends, all your class. It would be a huge favor for your end. For any private tutoring or classes, group classes that contains a lot more content than this, you can join. And always email me. I'll make sure to share the whole arrangement, and hope you get a very good grade. Take care, guys. Since you're enjoying the lectures, just wanted to inform you that there are premium batches going on. That is direct way to get A's and A stars. It has got some exclusive content that is not generally available neither on the website nor on the YouTube. So you can join the batch to get your grade.